Hello, my name is Jack Lattanzi, and I am demoing my Lab 9 uh, register bank and shift register today. I'm in Lab Section 5 at 9 a.m., and this is ECE 102. Okay, I'm going to share my screen now. Okay, so pretty much this is a two-part lab. The first part is designing a register bank, which works as which brings in 3 registers which can hold any data, and you have to be able to put data into any one of the 3 registers and get data out of any of the 3 and display it, as well as switch the data between the 3. So beginning here, looking into the design of the register bank, you can see that there is a decoder right here, which has a 2 inputs or an input 1 and an input 2 and an output 1 and output 2. This is the what is going to control the whole circuit. So you can see there's input enables and output enables. So the way the circuit works is the register has a value entered into the keypad, which is down here, which I'll explain later. It goes through the buses. This here, if the value, say, is of the input is 0, 1, then that means that from this connection, the input for this first register will be enabled, or for register 1, which is here. Then if the register, then the outputs would be set at 0, 0, because then it'll just display nothing, or it'll just allow that. And then it works the other ways too. So if it's 1, 0, then it will be register 2. If it's 1, 1, it'll be register 3. And then when the output is enabled, so say we put 1 into register 1, so it's 0, 1 for the input enables, and then you put 1 for output enables, so 0, 1, then it will give the output of this register and go around here and display it, and it will enter the binary to 7-segment display and display it. Okay, so the way the registers work are, here's the register circuit. There's 2 7417 registers given to us for this, and this is where we are connecting them to create an 8-bit register. You can see that the output and input enables are connected to both of these, so they are the same in this circuit, and it works as one. There's a data bus of 8 inputs and a data bus of 8 outputs. So that's how the register works. We use 3 of these in this design here for the 3 registers to store data. The way, so right here you can see where the keypad is controlled. This is kind of the main idea of the keypad. There's inputs of switches, and it goes through a tri-state buffer array, which keeps which controls whether or not the input is allowed. The tri-state buffer array is enabled through the output enabler, or the output enabler, which has to be set to 0, 0 if we're entering in numbers to the registers. Okay, so another way that this circuit works is that there is a clock pulse, which is common for all of them, as well as a clear up here, common to all of them. So we can clear the registers, and the clock pulse creates movement. Okay, so getting into how we implemented this is we first here entered in 1, which you can see this is set to 1, 0, or 0, 1, so that it's entering to register 1. This is set to 0, 0, so we know it's entering the outputs. Then we are displaying 0, 1 of register 1 here, and that's the correct formation of 0, 0, 1. Then we are entering here, so the inputs are on, outputs are set to 0, entering a 2 into register 2, which is then displayed here. These are the 24-bit outputs, which correspond to work in the 3/7 segment displays. So this is the correct representation of 1 or 0, 0, 1, correct representation of 0, 0, 2. And then 3 here is entered into register 3 and displayed correctly. Then here we are taking the information from register 1 and moving it into register 3. So you can see that register 3's input is opened and register 1's output is opened. So that data just flows into register 3. And then we are displaying register 3, which has a 1 in it because that's originally what was in register 1. So from this, we can determine that the circuit works successfully and that this entire design is functional. So looking into the design for part 2. So this is an 8-bit parallel in, parallel out shift register. So this design is made up of D flip-flops and 4 1 multiplexers. So you can see that the multiplexers are all down here across, and there's 8 flip-flops across as well. The way this circuit works is there's a common clock pulse, a common clear pulse to all of these to create movement in the circuit, as well as I'd like to say that there is a common function selector of S1 and S0. So the way S1 and S0 work is if it's set to 0, 0, then you can see that the multiplexer allows this one to flow, which is on D0 for every single one of these is the input. So that is pretty much set and sets the inputs in. D1, you can see is connected to the segment to the right, which creates, when it is 0, 1, it creates a shift left. Number 2 is connected to 1 to the left, which we can see that here, which creates a shift right. So the shift right is created when these two are equal to 1, 0. And then 3 is allowed to go when these are equal to 1, 1, and that just holds the value because it's connected to the same 1. So this is how the operations work. So the implementation of this is we started here by entering an 8-bit of all ones. So 8 ones in a row. Then we have our 8-bit output here. So to begin, the outputs are all at 1. Then here it is shifted 1 to the left, shifted another to the left, another, until they're all down to here. And it's shifted to the left 7 times, so there's only 1 of them on. And then it's shifted to the right, so 1's back, 1, 1, 1, 1, shift to the right, and then they're all on. So you can see this happening here because these are the functions right here. So 0, 0 is the enter one. Then 0, 1 is a shift to the left. So there's 7 shifts to the left. 1, 0 is a shift to the right. So these are all shifts to the rights. And then finally at the very end, it's 1, 1, and there's a hold value here. So from this, we can determine the functionality of this circuit because you can see that the values are all shifted to the left and to the right successfully. 7 times to the left, 7 times to the right, and held, and the input is entered. Okay, so this has been my demonstration for Lab 9, register bank and parallel in, parallel out shift register. Thank you for watching. I'm Jack Lattanzi, Lab Section 5, ECE 102.